Okay, let's start. We definitely have to start with the design patterns on Thursday for sure. So today the plan, I will finish up everything about polymorphism, dynamic binding, just to finish the review. And then we'll move on to a small topics about generics. We're going to revisit generics briefly, just to give you a little bit more insight into the issue. And then we'll start design patterns, which will be useful for your projects upcoming. Okay? But for tomorrow's lab session, please come. I'm going to do a little bit demo to help you with testing your lab 3 and also the project later. Okay? I'm going to announce that later tonight. All right, so let's review quickly. So this is basically where we started with before the reading week. I'll just tell you very quickly. So if you want to do casting in IFO, always use the syntax over here. Don't memorize it. We'll maybe give you a cheat sheet during the exam, so remind you the syntax. Okay, just understand the idea. Always compiles. All you have to know now is to see when it will give you assertion violation error at the runtime or when does it not. Okay, that's basically where we left off last time. Okay, so that's something we went through. I just want to go over the example together with you very quickly. Okay. So now, basically, what you have to know is the principle, okay? Basically, the principle is this. Let's just go over abstractly very quickly and then go over example. So when you have a runtime assertion violation, it is when the dynamic type somehow cannot satisfy the cast type you're trying to do, okay? The expectation. Okay, let's see what exactly that means, okay? So let's see the example that we had about smartphone, okay? So typically, you would just be given some inheritance hierarchy over here. Let's say this. Let's consider 2 different casts that will actually be okay, because somehow the expectation created by the cast can be satisfied, positive. Okay, let's see the first case over here. Again, let's have a look. So now we are trying to declare this particular variable here called myPhone of static type iOS. So what I would do is, I'm just going to use my convention here. So green for static type. Static type is simply iOS, so this is where it is in the hierarchy. And then we are trying to say, create that to be iPhone 11 Pro. So this is that dynamic type. So now, before we go into the example, you want to, as soon as you mark on the inheritance hierarchy, what kind of type are you supposed to cast that into, right? It turns out, let me tell you the rule right away. It depends on what the dynamic type is. So you can see currently the dynamic type is simply just over here. That means you can cast your variable to either this type or its ancestor or its ancestor's ancestor, all the ancestors. Okay? If, hypothetically, if there was another subclass over here, let's say, you cannot cast this into this or lower because you cannot satisfy their expectation. Because the lower the class is, the more expectation you may have. Okay, that's kind of the general principle. Now let's have a quick look. Let's see the very first case we are trying to do the cast. So now over here we're trying to say we're trying to cast my phone into smartphone. Okay, so now we are trying to do an upcast. So you can see I say either upcast or downward cast. Whenever you're doing an upward cast, that means you're narrowing down the feature that you can actually call because it's upper, right? So in this case, you can see we are trying to do smartphone. So this is the alias we're creating. Okay, again, what does cast really do? Let me just draw the picture just to remind you. Okay, after these 2 lines over here, what we have is my phone is actually pointing to a iPhone objects over here. Okay, it's iPhone 11 Pro. So every time for dynamic type, we'll simply write it down on the box. Okay, so this is what happened after the first 2 lines. And then what does cast really do, this line over here? What it does is we are not trying to create any new objects. What we're doing is we simply create a new variable sp over here, and then we got sp. sp is pointing to the same object, so that's why I say it's an alias. So now, what will be the difference then? A little bit test on you. Yeah, actually, SP and myPhone, they're pointing to the same objects. They're alias of each other. However, what would be the difference between them? Static type? Yeah, exactly. Okay, just a reminder. Okay, I'm pretty sure you got it, but I'll write it down. So for myPhone, it was declared to be iOS, never changes. And SP was cast into smartphone. I'll say SP over here, smartphone. Okay, that's a static type. So this is why when you try to review the notes, what feature can you call on SP, basically? You can see for SP, it's simply just declared to be smartphone. So all you can call will be dial and surf web, and that's it. Okay, that's the consequence of making an opcast. So let me just tell one more thing before I move on to the next one. You can see that for SP, even though it is pointing to an iPhone 11 Pro objects, however, the only feature you can call on SP would be just dial and surf web, because it is a static type you're trying to cast that into. So that restricts what features you can call. Okay? If you're still having this kind of trouble about expectation, how to do upward, downward casting, please let me know. Okay? Here's just a quick review. Yes?
So obviously, quick take is a feature that SP can call, right?
Cannot. So you're talking about quick take. Okay. You're basically asking this. Let me just repeat your question. You're asking, can we say SP over here dot quick take? The answer is no, you cannot. Because from the compiler's point of view, SP has the static type smartphone. Smartphone does not support quick take, even though SP is really pointing to iPhone 11 Pro. If you really want to call that feature there, you will do something that we'll do in the next slide. You got to do some downward casting.
So is the compile time error and the compiler is checking what the type is of SP?
Exactly.
To determine which features it can call.
That's exactly right. So
The object still pointing to object.
that's exactly right. So remember before the reading, I briefly mentioned that back in 2001, you learned something called undecidability. To really inferring the dynamic type of a variable at any point of time of your program is undecidable. Your compiler simply just cannot do it. Okay, yeah. Okay, guys, again, it's very important. So whenever, if the compiler wants to decide whether a feature call should really compile, all they look at will be the static type for the context objects. In this case, SP, its static type is specified in the cast. Okay, let's do just one more, similar. But now this time, okay, it's similar setup. So let me just write it down first. So we know that iOS, again, is a static type. I'll put it here. And also, we have the dynamic type is still iPhone 11 Pro over here, static and dynamic. So now what we are trying to do is to cast that into itself, basically, which is OK. You can cast to any class you wish. So now let me just say blue. So we are trying to cast that into iPhone 11 Pro. So now the question is whether having a runtime assertion violation or not depends on whether the blue can actually satisfy, oh, sorry, let me say it again. Whether a runtime assertion error might occur depends on the following. Whether the pink, which is the dynamic type, whether or not it can satisfy the expectation of this particular static type that we're trying to cast into, which is blue. That's how he judges. In this case, can it? It definitely can, right? You can satisfy its own expectation. So in this case, you can call quick take, right? Good. Pretty good. So that's basically where we end up with before the reading week. Let's do a little bit more. Let's try to think about why violation might occur at the runtime. Okay. Let's have a look at. We got 3 different cases. I'll be quick. Okay. Again, let's set it up. It's a different variables. Let's just do it properly. So we talk about a phone called mine over here. Okay, just call it mine. And then the static type is simply Android. I'm going to put it here, just the other side of the hierarchy. And then what about the dynamic type? Let's say over here we say initial dynamic type simply Huawei. I'll put it here. Okay, that's a setup. So now, before we do anything, okay, we know that in iPhone, you can cast mine into any type you like. Compilation is not an issue. Okay, compilation simply always work. Can you tell me which classes I can potentially cast mine into without getting any runtime assertion violation? What classes? Michael? Yes. Okay, let's try. So the question is, and then I'll take your answer. Okay. So the question was, I will put maybe just green as a safe, right? So now, question is, what type can we cast mine into without having any runtime assertion violation? Tell me, what classes? Android, I agree. You can cast that into it. You mean this one? Are you sure about that? Well, think about this. I'll definitely go over in detail. But Jordan, do you think that might be okay? You gotta be an upper cast, exactly. So, exactly, yeah. Intuitively, Michael, you can think about, actually we do have some example over here. I'll just mention that. The reason that you cannot cast that into this is a downward cast. Compilation is okay, but you're gonna run into runtime trouble. Because this particular class, which is lower than the dynamic type, and which means it potentially might have more expectation. In this case, yes, it does. Zone niche, which is not supported by dynamic type, so it might crash. Okay, so that's why you got runtime assertion violation for cast. Okay, so good. Let me just unwind a little bit. So the type you can cast will be everything that's the dynamic type or its ancestor. So the green 3 classes are all the classes you can cast into without any trouble. Okay, everything else will cause you trouble. Everything else. So now everything else, I'm going to say red. If you try to cast that into iOS, this one, this one, this one, this one, this one, this one, this one. All these classes will compile if you try to do the cast. However, they're going to cause you trouble because their expectation cannot be met by Huawei. Okay? Question, please.
If you made another class called like Huawei Code, and then it had the exact same code in it, like features, and then you cast it to Huawei Code, would it?
You're trying to make a subclass or? I might see what you're going. So you're saying you're trying to make a new class over here?
No.
New subclass? Under where?
Under descendant of Android.
Sure. Let's call that. Let me just call that. How about C1, for example? Okay. And then?
It has all the features that Huawei has. And it's the same way.
It's a very good question. Okay. The question was, let's say we simply copy and paste Huawei into C1. They contain exactly the same code. And now, if I try to cast mine into C1, what's going to happen? Let me write it down, okay? So now, think about C1 is exactly the copy and paste of Huawei. Got exactly the same feature, okay? So now, if you simply say, I would say check, attached, and then I would say C1 over here, and then mine. Again, compilation is no problem, okay? You will run into runtime assertion violation. Assertion violation. It will still be. Even though you think you're simply just doing a copy and paste. For the runtime manager, they simply don't care. All they see is you're trying to cast Huawei into something that's not its ancestor. Then it will give you a runtime assertion violation. They don't do any detailed check to see whether do a diff to see if the 2 classes look the same. But what if they simply look very the same, but they just rename the variables or features, right? They didn't go that far. So as long as the class you're trying to cast into is not an ancestor class of the dynamic type, it's going to give you runtime assertion violation. Yeah, I guess it's a good question. Yes? You want to change the dynamic type?
No, I'm saying you made it as Android, so then why
No.
does file work when you cast it? When you create it, you cast it, why does that work? Should it only work for Android?
No, it's different, it's different. Okay, so you may be a little bit confused with this. So over here, yeah, this line over here, this is declaration, right? We are declaring mine to be of static type Android. That one doesn't change ever, okay? This line over here, we're using the create, like a new keyword in Java. We're creating a new objects of type Huawei. So that's now the dynamic type for mine, static and dynamic. So now we talk about given the static, given the dynamic, so now you can see what class you can cast into. All right, guys, any questions? Okay, I think this covers even more general than what's said in the slides. So, Chelsea. So say it again, sorry? Correct. Oh, correct. So whenever, yes, that's correct. Let me just repeat. So what you observed was, whenever you're trying to do a cast, you have to pay attention to, number 1, what's the dynamic type? Number 2, what's the ancestor path of the dynamic type all the way to the root? Okay, that's a judgment. Okay, so now, without going into too much detail, let's see this. Can we actually now try to cast mine into smartphone without any violation? Yes, smartphone is actually here. That's a green one. Okay, very good. It's covered. So now, without the annotation, can we cast? Okay, let me just remind you. Okay, remember this is dynamic type. Okay, can we cast to Huawei itself? Yes. Thank you. Yes. Okay, next one. So now, again, dynamic type. Can we cast that into Samsung? No. Thank you. No. And now, still here, can we cast into Huawei? Good. You guys are pretty good. All right. Would you feel comfortable if we put this on the exam?
If you put those same comments on it.
Eh?
If you put those same comments on it.
Put those same comments? Oh, you mean like, well, I could. Yeah, Michael, yeah, question. Okay, good. Okay, let me just say one more time. No worries. We'd rather get it right, okay? Because you're gonna need this, okay? Okay, first of all, are you okay with the fact that we actually have dynamic type being Huawei over here? Good, okay. That's because this line over here. Yeah, no. Actually, you can see, first of all, this is static type, agree? So now, dynamic type, dynamic type can be a subclass of static type. That's actually covered in the previous lecture. So that one's not a problem. So now the issue is, given that this is the dynamic type over here, okay? Dynamic type. So now, if you're trying to cast that into this guy over here, okay? Think about if the cast was okay. Let's assume it is okay. If this was okay, so that means we should be able to call zoomage on that alias. Agree? However, zoomage will not be supported by this particular dynamic type that's currently there. It will not be supported. So it wouldn't allow you. That's why. Yeah. Think a little bit more about the logic over there. Yeah. Static type in this case does not play any role over here. Static type will be very useful when you want to judge, for example, whether a feature call will actually compile. Okay? So for example, let's say here, let me show you. So now just for example over here, let's say let's say this guy here. No. Okay, let's pay attention to this line. Okay, all of you agree with me before this will not give us any runtime assertion violation. We are simply trying to cast into smartphone. Now, if I say SP is actually pointing to this particular Huawei object. Agree? First of all. Okay, I'll just say Huawei over here. Okay, it's pointing to it. But from the compiler's point of view, SP is of type smartphone, right? From the compiler's point of view. Smartphone, I'll say SP over here. Okay? So now, can I say SP dot, let's say, Skype? No. Why not? Exactly. So that's exactly right. So this is where the static type can be useful, because now SP, from the compiler's point of view, is only smartphone. Smartphone only support down to this level. It does not support Skype. Okay? Yeah. Guys, are you comfortable? Okay. We're gonna see a little bit more later. Okay. So that's about a cast. I would say cast might be the most tricky thing to actually consider when you talk about polymorphism and stuff. So now let's do something a little bit easier. Okay. We just have to review how polymorphism and dynamic binding works for feature arguments and also return type. Okay. So now let me ask you something from 2030 quickly. Okay. Remember back in 2030 we talked about something called Callbyvalue? Ring the bell? Yes? What's Callbyvalue? Anybody? Callbyvalue? Jordan, does it ring the bell?
Not the same as dynamic binding, is it?
No, nothing to do with it.
Actually, when you call a function, you pass only the value, not the reference. Is that
That's correct. Yes, when you try to call a function, we'll call a method, we'll call a feature. You pass just the value of the arguments. But now the argument type can be primitive type or can be reference type. If that's primitive type, just copy the value. But what if it's a reference type?
you don't copy the address?
You copy the address, actually. You don't copy the contents. You just copy the address. Okay? That's call by value. Okay. Let me just make it a little bit more explicit for you, because in order for you to understand polymorphism for feature arguments, you need to review a little bit call by value. Okay, let me just go over some slide with you. We'll do examples. Okay, let's say this. This is the kind of thing you will see more in the design pattern. That's why we want to make sure you're comfortable with it. Okay, let's say we have a class called Student Management System. Okay, we already said goodbye to the smartphone example, right? We wouldn't see them anymore. So just back to students. Okay. So now student management system here. So let's say we got an array, SS of type array of students. So now, as soon as you see this declaration over here, okay, let's focus on this line specifically. This guy here. Okay, just this line. So what does that mean? We are doing a declaration. So that simply means for this particular array, we are saying that every element in the array has this particular static type. That's what we're saying. Not dynamic, static. We're doing declaration. Okay? Just keep that in mind. So that's why I said there in the notes, SS at any valid I index has a static type students. Are you comfortable with it? Okay? So now let's go on a little bit. Okay? What I want to do is go back to the slides a little bit. And then let's say we got, three different commands over here. One is called add s, as students, and then the feature, the parameter type is students. We got another one called rs, add resident students. You can see the parameter type is different, right? Let's see another one, add nrs. Again, the parameter type is different. So now you can see somehow I'm pushing the polymorphism issue rather than just talking about simple variables. We talk about parameters, okay? That seems to add lots of complication, but it's actually not. As long as you can feel comfortable about call by value, everything is just the same. Okay, let me explain. So now think about if I want to call something like this. First of all, let's see one thing here before we do the call by value thing. I want you to consider this. Let me just clean it up. Okay, I want you to consider this line over here. Let's say we consider this particular feature here, add s, and then can you tell me whether or not this line should compile, first of all? I heard yes, okay? How would you judge, right? So now, Michael, in this case, should we worry about dynamic type or static type? That's okay. So we talk about the pink line over here, SS at position 0 should be assigned to S. We're asking whether they should compile or not. So now, should you think about static type or dynamic type? Exactly right. Okay, so now let's see this. Okay, let's see this very quickly. So now what you will see is static type. For S, it will simply declare to be of type students. And then what about SS0? It depends on what the type is for this SS. And every member has a static type students, as we said. So now is students a descending class of itself? Yes, so this will compile. Okay, that's one thing to note. Okay, and then you should be okay of telling me whether this is going to compile. Yes, okay, because now for RS, the static type is resident students. And then SS position 0 is remain to be student static type, right? And resident students is a descending class of students. Okay, so that also compiles. So you can see what's happening over here is we are trying to store different argument values into the same array, SS. Simply because SS, the static type students, being so accommodating because it's on the top of the student hierarchy. So you can store either students objects or resident students objects or non-resident student objects. Okay, that's why. Okay, it's really important. Okay, and let's go a little bit further. Okay. Okay, so now we want to actually have this call by value business. Okay, if you look at that, I want you to look at this. Call by value, and then let's look at sms.add_rs. I simply give an object O. Okay, that's exactly what Jordan just mentioned. Call by value addresses when you are trying to make a method call, feature call, or function call. Doesn't matter, just a call. Right? So now SMS is the context objects, and @_rs is the feature we're calling, and O over here is the arguments. Okay, what we learned back in 2030 is as follows. Okay, let me tell you this. Okay, let me write it down. So now, when you look at this, let's say this line particularly, if I say SMS dot @s, I'm basically talking about this feature specifically, this command. The parameter is s, the argument is o, right? This is arguments, and this is parameter. What the runtime would do for you is something implicit. You will simply do the parameter s is simply assigned to the argument o. That's what it does, always. This is how we fill the gap between what we just covered and the feature arguments. All you have to understand is you're always doing this implicit assignment to assign the arguments into the parameter. Okay? So now, are you comfortable with this? Okay. If you're comfortable with this, let's see how we can actually do some examples. Oh, yes. Oh, okay, thinking this way. Let's talk about this one here. Okay, let's just do a little bit more detail. Let's say we talk about this line over here. Okay? So what we are really doing is, let's say this. So what this will do is we'll talk about this feature, this command. This is a parameter, right? So we are doing rs is assigned to o. So under what circumstance is this line going to compile? The static type of O must be a descending class of the static type of RS, which is resident students. Agree? Okay. Guys, are you following? I hope. Are you comfortable with the Callbyvalue? That's something I want to make sure you can follow. Okay. Yeah. Okay. How about we do some example? Okay. So I'm just trying to say O can be any static type. So what you have to know in your mind is to see under what circumstance can this line compile. Okay? Let's see. Okay? Let's try this. Okay, so that's kind of the example you will see in your slides. Okay? But now let's just do one or two of them. Okay? And then you get an idea for the rest. Okay, let's see what we know already. What we know is we know the static type for every element in SS. We know the static type for the parameter for each of the 3 commands. That's what we know. Okay? And now let's see this. You can read this very quickly for me, okay, just to see what variables we have. Apparently we're declaring the static type. Okay? So now I want you to consider this particular line, orange, and tell me whether or not that should compile. I heard yes. Okay. Anybody would think that's no? Okay, why don't we analyze together? Okay, let's try together. Okay. So now think about what's going to happen. RS is the arguments, and then we talk about this particular @s, which is here. And we talk about this particular parameter, right? So implicitly what we do is S, the parameter, is assigned to RS. And now we can do our normal check. Static type for RS is resident students. Static type for S is students. Is RS, resident students, a descending class of students? Yes, it compiles. So you can see the only extra step you have to go is by looking at this implicit assignments. That's a key. Okay? You will see that for the design pattern that we talk about, you need this kind of polymorphism often. Okay? Shall we do one more? Okay? Let's see this guy here. Okay, I'm going to use a different color. Okay? How about this guy here? Pink. I heard no. It makes sense because I talk about one example where yes, the other one should be no, right? But now, can anybody explain to me why no? Yes, please. Explain Java. You can do it now in the class, but in the exam you'll be in trouble. You know that, right? But no worries. You can explain Java, whatever you like.
You can see S1 as a array list, as like it's expecting an array list, but you are sending list, which is interface.
Oh, I see what you mean. You basically talk about the connection between ancestor and descendants. But I would say yes, for sure. For small scale example, you might think it that way. But I would say try to adapt to the way that we are trying to think. It's not specific to iPhone. So I would say what you're thinking is not specific to Java either, right? You're just making yourself too much into array list and list, right? Yeah, that's okay. Anybody? Yes, Chelsea.
At RS is expecting the resident student remains descendants, and S1 is just a student.
Exactly. Okay, so now again, S1 is the arguments. Add RS is now having parameter resident students. Implicitly, we have RS is assigned to S1. Okay, S1 has a static type over here, students. Okay, static type. RS has a static type, resident students. Is students a descending class of resident students? No. Okay, it doesn't compile. Any questions? Why it doesn't compile? So it goes back to our very discussion about, first of all, Michael, are you okay with if we say, when you call, let's say we call this one here, when we're making this feature call, would you feel comfortable if we say implicitly it's like RS, the parameter is assigned to S1? Okay, very good. So now you're basically asking why this shouldn't compile. Again, think about proof by contradiction, as we said, when we first did a review. Proof by contradiction. If we allow this to happen, okay? So now at the moment, S1 is a student's static type, so it can only point to a student objects over here. And now we are saying we want to assign S1 into RS. RS, if we allow, let's say hypothetically, if we allow this to happen, okay, let me put a question mark. Should we or should we not, right? Let's say we allowed. RS has the static type resident students. Resident student is a lower class than students, agree? So that means we have more expectation. For example, premium rates. In that case, you can say RS dot premium rates. That's absolutely fine. But does premium rates exist in these student objects? No. So you might just run into crash. That's why it wouldn't allow it to compile in the first place. Yes. The consequence is crashing, right? Yes.
What if students have a parent class and on the outside function call, you declare the static type of the parent class of student, and then you cast into a descendant class of student, and then when you pass it into the function, and you try to cast it again to the parent of student,
that sounds very complicated. I would suggest to really not to get distracted. I kind of know what you're asking. You're just talking about some very complicated route to get something to work. Why don't you talk to me after class? I'll organize the example. I'll mention to the class. That'll be better. If I do it on the fly, it might take 1 hour. No, I'm exaggerating. Not 1 hour. Yeah. Okay. Just mention to me after class. I do want to discuss that. Okay. Good. Thank you. Any other questions? Yes.
Just simplify. What will the precedence, like the casting or the actual feature call? What would take precedence? Just a quick answer. Like if you were to do casting or feature call.
I would say, yeah. So you wouldn't really do the cast inline. Okay. Think about what's a general form for doing casting and feature call, right? So you might say something like this. You might say check attached. For example, let's say S of type students, for example. Let's say we are very sure S is pointing to a resident student object. Let's say we are very sure. So this is time to use casting. Attached, let's say resident students, let's say. S, RS, okay? Okay, I put S here, okay? Then, in that case, I can say SMS dot add resident students, and then I can put RS over here. Okay, let's see why this will work, okay? Let me just say this is RS1, okay, RS1, that'll be easier, okay? So now think about what's gonna happen. will this line compile? Okay. Implicitly, we are calling, first of all, we are calling this add rs feature, right? Implicitly, rs, the parameter, is going to be assigned to this argument, rs1. Should it compile? Well, rs1, what's the static type? Rs, the cast type, right? What is the static type for rs? If you go back there, add rs is a static type rs, okay? Resident students. So now the question is whether rs is a descending class of itself. Yes. As you follow this example here, it's slightly more complicated, right? So that's useful, which means if I cannot pass s into add rs directly, I can do a cast. That's how you do it. Yes. The previous slide?
So we can define the array as student as static type, right? So does that mean in order to store the element in the student array, so it's a static type?
Yeah.
All the elements have to be the form of static type?
Yes, so basically for your, okay, you're talking about this particular attribute here, ss, okay? The static type for every element in the array is students. However, the dynamic type for each element in the array might be any descendant class of students dynamically. It can be students, it can be resident students, or it can be non-resident students. We'll see, okay? Let's go a little bit further, okay? Yeah, sure. This one?
Yes. If you made a static type as a descendant of rs, the check attached would compile, correct?
Okay, you are saying the following. Hypothetically, you want to say, rather than students over here, you want to say, what about NRS, for example? Okay? So now, okay, we can try this. Okay, guys, it's a different exercise. The only thing I changed was the green. Rather than having static type of S being students, it's now NRS. First of all, will the cast compile? Compile. Compilation is not a problem, okay? I'm tricking you, right? It's not a problem always. So now, are we going to get a cast violation? Runtime. Are we going to get a runtime violation? So now think about what we're doing here. Let me remind you how the hierarchy looks like. We have students over here, under which we got resident students, and also we got non-resident students. For this particular new example over here, the new static type is NRS. That's a static type. And what's the dynamic type? The only possible dynamic type is NRS, right? There's no more classes lower up. So now what I can do is, let me just do one more line to show it to you. So after this, we can simply say creates NRS s.make, right? So that means the dynamic type at the same time is also NRS. So now we are trying to do the following cast. We are trying to say, I want to cast into RS. Can I do such cast? Well, apparently yes, right? Once you see on the diagram, because if you are trying to cast into RS, the expectation on RS, for example, premium rates, cannot be satisfied by the dynamic type for NRS. There's no premium rates. All right, good.
So just because it compiles doesn't mean it actually gets cast.
That's correct. So compilation, again, is not an issue here. It always compiles. It's just about how you can get, whether or not you get a runtime cast assertion violation.
And the line below it doesn't create a compiler.
The line below?
The add.
No, it doesn't. Because as far as the compiler is concerned, it only consider the static type for RS as this. RS1 is RS, as far as the compiler is concerned. Okay?
And then if we were to put like NRS in that feature call, like outside of this, it would fail because it's expecting a resident student.
So if you, let's say this, first of all, this particular fragment of code is going to compile. That's not a problem.
Yeah.
Okay? So now, if you try to execute this fragment of code, you're going to run into runtime violation. But at which point, right? Basically, if you try to execute this line of code, you're going to fail exactly over here, just over here, just over here, just there. Because for that case, you are trying to cast this particular dynamic type into RS. That's simply not allowed, right? You can only cast into the ancestor class of the dynamic type without any contract violation. Okay.
And can you go to the slide deck?
Sure.
The example of the exercise you were doing before?
Mm-hmm.
So the one on the right, that's a compile outcome there, correct? The purple one?
Yes, correct. No, yeah, the pink or the purple, yes.
Okay.
Mm-hmm. That's correct. The right-hand side, yes.
Okay.
Yeah, again, whenever you want to see whether something should compile or not, only look at the static type. If you want to know if there will be any runtime assertion violation, look at the dynamic type. Okay? Yes?
How are you able to see if the check assertion failed if you didn't have the dynamic type? You didn't create it yet.
Oh, yeah, so you definitely need to. I just kind of simplified that a little bit. Because in that case, because static type, if that's, okay. So I agree with you. So what you're concerned about is, that's why I added this line over there, right? That's why I added this line.
Oh, okay.
Now you got the base, for sure. If you want to see, you're definitely going to see a dynamic type. Yes. All right, let's do a little bit more example over here quickly, okay? I'll try to go over this quickly, and then we can go to return type, okay? Okay, let's see. So now what I will do is, so now let's try to consider this particular test, okay? So we're basically trying to create objects over here. Now, first of all, we're going to see create rs.make. So now rs is resident students. Okay, so now we got a resident students. So we're going to say rs is pointing to this particular object is Jin. Okay, set a premium rate to be 1.5. Okay, and then initially the list of courses will just be empty initially. Okay, I'll just say initially just empty. Okay, and then let's try another one. We create another non-resident students over here, Jeremy. Okay, NRS is Jeremy over here, and then we'll put Jeremy here. And then set a discount rate to be 0.5. And also, the number of courses registered for him will just be empty. Okay, so now let's see this. What we want to do is to create another object here called SMS for student management system. So SMS is student management system. Remember, there's an attribute there, SS. It's going to be an array of students. So now we call this array over here polymorphic array. Let's see exactly what I mean. So now these two lines are very important. These two lines. Okay? You can check later when you study the notes. I can tell you that these two lines compile. Because the static type for RS and NRS simply are descendant classes of the parameter type. Okay? If you do the Callbyvalue analysis. Let's see what the consequence would be if we try to do that. If you try to execute this line over here, we say add s and then simply do rs. What that would do is you simply say ss at position 0 is assigned to rs, right? The first position. Okay? So that means ss is pointing to some array, and the first position there is now going to point to rs. I'll say position 0. I'll put 0 here. So now you can see that static type, let me ask you this. Remember, so students over here, I simply changed that to linked list, but the same idea, right? The static type for each element in the linked list is simply students, okay? Now, SS at position 0. What is its static type, first of all? Students, never changes. Only look at that, okay? Students. What about its dynamic type? Well, because it's pointing to this resident students, okay? So far, so good. And then let's try one more. And then we try the next line. And then we try this line here. So NRS. So that means the second element in the array is now going to point to this particular object over here, okay? That's index 1. So now, same question for you. SS at position 0, what is its static type? Students. Again, never changes. Dynamic type, non-resident student, right? It's pointing to there. Okay. Non-resident student. So what can we observe? If you look at that, SS, the same array or the same linked list. Okay, I meant students over here. Okay, the same linked list. Every element there has the same static type students. However, dynamically, they might point to different objects as long as their dynamic types are descendant classes of students. Okay, that's why you see resident students and also non-resident students. Are you comfortable with it? Yes. Yes, I agree with you. Absolutely. Absolutely. Thank you. Yes. I would say you don't have to worry about runtime violation just yet. So far, it just worked well. I tell you what, this is actually what normally should work in the design pattern that we're going to talk about. When we declare the linked list or the array, the collection, we simply say the static type for every element is simply of a type that occurs at the root of the hierarchy. Dynamically, you can actually store any elements as long as their dynamic types are descendants of their root. Okay?
Is there a way to pass an object and return its type?
Pass an object, return its type. Not that I know about. I think in Java, you can say get class. Remember back in the 2030, we learned about the equals method. You can say something.get class. I'm not too sure if IPO supports that, but I don't think you usually need that. Okay, yeah. Okay. Okay, so now let's go a little bit further. Okay, so now if you try the following, okay, let's say this line is also important. So what we have seen, this is so-called polymorphic array or polymorphic collection. Let me write it down. This thing over here is called polymorphic, polymorphic collection. I said it already, okay? So now let's consider another important line. Okay, can you consider this line over here? When I say SMS, so now the context object is the student management system. I say register all. What that would do is to go to the student management system class and register all. Simply go across the students, and then for each item, for each student we are talking about, I just use a cross S. Okay? I simply say register. Can anybody try to explain to me how dynamic binding is going to work when I try to execute this across loop? Okay, I'll let you think about it. It's actually quite important. Anybody? Yes, you want to try?
Look at its dynamic type and then go with the version.
So first of all, how many iterations are we going to have for this register all? Two iterations, right? So the first iteration, we're going to encounter, okay, so let's see this. So when we execute this particular cross loop, okay, it's going to have two iterations. So the first iteration, s.item for the first iteration is going to refer to position 1, which refers to this particular object dynamically. So now if I say register on that object, I'm going to consider the premium rates for that particular students, right, for register. Now if I go to the second iteration for the loop, I'm going to encounter a different dynamic objects, which is non-resident students, in which case registration will consider discount rate. Okay? That's how dynamic binding works. So now why it is so important for a polymorphic collection? Once you decide the static type for your collection, dynamically you can store anything that's a descending class of the static type. So every time you call any expectation feature on that particular element, you just get a corresponding version from the descending class. That's what's going to happen. Okay? Try to get as much as possible. We definitely have to reinforce this when we see the design pattern. You will see many, at least 2 or 3 more occasions, but it's a first exposure. Okay? Any questions for me up to this point? Okay? Maybe study this example carefully. Okay? You definitely need it. Okay? All right. After this, what we will do is we'll do return values quickly. Okay? So now after this, we'll feature called augment. Okay, that's exactly the test we just did. And now let's do, okay, that's just more exercise for you to see which one compiles, okay? I wouldn't waste your time, okay? You can look at that when you study the notes. Okay, so now we talk about, okay, so now this is also something very important. So why do we need inheritance? If you think about the very first version of the solution, we didn't have inheritance. In that case, to really have a student management system, we need to have one single array for all the resident students, have another array for all the non-resident students, 2 arrays. But now we can only have just a single array, where in the single collection over here, the static type is simply just students. All we gotta do is to support either just this one, add students over here. Dynamically, when we try to add students into the collection, as long as the argument type is a descending class of students, which will include resident students and non-resident students. And we can add both kind into the collection. And then when you say register all, dynamically, it's going to go through and then see which one should call. Okay? So think about this example more. That's really crucial. Okay? Can I emphasize more? All right, so let's now go to return value. Okay. Return value is also not too bad. Okay, let's see this. Let's say we still got this particular, so this is what we have known so far. Okay, let's talk about this particular one, number 7. We are declaring a query or accessor. Given the index, let's say index I is valid, let's assume, okay, just for simplicity. Given that line number 2, we have SS being polymorphic, which means dynamically, either students or resident students or non-resident student may be stored in the collection, okay? So now, what can be the possible dynamic type of the return value from line number 7, if we call that? Can be resident students, can be non-resident students, can also be students, right? You can see now, what's the tricky thing about this? I'm going to show you exactly how that's going to happen. If you look at this particular type over here, this is the static type of the return value, right? Statically, it can return just as students. However, that return value might actually point to some resident students objects dynamically, right? So now let's see how. You can see, okay, I got a precondition there. The implementation here is as easy as just line number 10, just say result is assigned to SSI. So now, question for you. Should line number 10 compile? I heard no, but I wouldn't mind if you want to explain why no. Okay, that should be a yes, right? Okay, why yes? Okay. Yes, correct. Okay, SSI over here is of static type students. And then, what's the static type for result? Students, right? Think about result is like a reserved keyword in IFO, which means result should have the same static type as the return type. Okay, that's how you think of it. So now you think about the assignment, students is a descending class of students. Of course, that should compile. Okay, let's go over some code very quickly, and then we can talk about some design principles. So now let's see this, return values over here. Okay, let's see. So now we have this. Let's just go over very quickly. Okay, so these we have talked about already. Okay, so let's focus on this particular test over here. So now let's say again we got RS, okay, which is resident students. Okay, let me draw very quickly, Jim. And set premium rates 1.5, and for courses just empty to begin with. Also, we are trying to make NRS. And then it's Jeremy over here. And set discount rate to be 0.5. Okay, it's also empty courses over here. So now we also create an empty student management system, right? So SMS is pointing to this object here. Initially, as the number of students will just be empty to begin with. So now let's focus on these two call, which we went over already. This guy here and this guy here. This will create a polymorphic linked list that we talk about, right? So what this will do is, for the first one, it's going to make sure that first elements in the number of students will point to this object over here, right? The first one. And the second one will make sure it is now going to point to this guy here. And notice that the element type are different. You can see one is resident students, the other one is non-resident students, polymorphic. That's what we know from the previous example. So now my question for you is, look at these two lines. Yellow and pink. Actually, how about green? You can see for yellow and green, we are trying to call the tuition feature from the student class, right? Remember in the student hierarchy, we have two different versions between resident students, which uses premium rates, and also in the non-resident student, which uses discount rate, right? Two different versions. Question for you. For the yellow line we are calling, which version of the tuition are we calling? Are we calling the one with premium rates, or are we calling the one with base rate only, or we are calling the one with discount rate? Okay, so now which version you will call depends on dynamic type. We talk about runtime behavior. Okay, let's see this. If you want to see it, so now see this. Get students 1. So get students, when you say 1 over here, so that means it's going to say result is going to be returning 1. So I beg your pardon, I should have put 1 and 2 here, okay? Started with 1. I got myself confused, sorry. Okay, so now you got get students 1 over here, so it's now SS1. So now SS1 is now going to return this particular objects. Agree? So that means when you call this tuition here, it's going to apply premium rates. Okay? Similarly, so now if you try this guy here, get students 2. So now it's going to be 2 over here. So now SS2 is going to refer to this particular one. Dynamically is non-resident students. So now it's going to apply discount rate. So that means this one here is going to do discount rate, and this one premium rates. That's why the numbers are different. Yeah, I just want to point to you very quickly how you should really analyze the behavior. You can look at it more details when you study the notes.
So can you flip over to the other slide?
Sure.
The one that you were setting us up for the
Poly,
get,
you mean this one here?
go this way.
I think that's the one. I think that's the one.
Oh, okay.
So which part? Tell me which part you're stuck. By the way, that's the last one for the polymorphism. We just need a little bit more design principle to show you, and then we are done. And then we go to generics. Yes?
I thought with the get student, we're expecting a static type of student, right?
Oh, okay. First of all, okay, let's talk about this. Guys, let me mention one more thing for you. So there are two issues over here. I'm going to write it down clearly. When I say SMS dot get students 1 dot tuition, okay? I'm referring to this particular diagram here, okay? So now, two questions for you. Question number 1, does it compile? Question number 2, if it does compile, which version of tuition is going to be run? Okay. Number 1, would it compile? Okay, so now here's a critical thing. Why would it compile? Aha, so now for compilation, we look at static type, right? So now if you think about it, first of all, we know that SMS is of static type, student management system. It does have the get students feature defined. Its return type, let me remind you, is simply just students. Okay, let me just get back to the code. Get students, sorry, just right here. right? Get students simply returns statically students. Does student class support tuition? Yes. That's how you judge. So now, which version will be called? In that case, you have to look at the dynamic type. In that case, you have to look at dynamically at position 1 is referring to this particular object over here, which has a premium rates. That's why dynamically it will call the version which uses that premium rates. Okay, so 2 questions here. You got to be clear. Okay. Question.
So RS originally it's static type was resident student.
Yes, for sure.
And then when you do SMS dot add s.
Oh, yeah, of course, because remember, you talk about, for example, RS, right? That's what you're talking about. Okay. RS, it is correct. This is a static type. But don't forget, when we say create rs.make, remember, implicitly, we mean RS over here, right? If the static and dynamic types are the same, right?
And then RS's static type is still.
Resident student. Static type never changes. Okay. That's for sure. Mm-hmm.
And then when it gets added into that array, does its static type doesn't change either?
Doesn't change.
So I thought the get student.
Get students, basically, you want to think about what's the return type, right? So when the return value, when you say get students 1, okay, think about this. When you see get students 1 over here, okay, statically, it simply corresponds to the return type for the get student, which is students.
So I don't care about when I call that function, I don't care about the static type. It doesn't check the static type of what it's returning.
It does check, because over here, when you look at the feature call here, in order to decide whether this feature call should compile, you look at it statically, what's returned by the get students. Statically, it is students, right? Nope. Students. Statically. No, we are focusing on this particular feature. If you only look at this feature over here, or what you're confused about is like this. Let me write it down. SMS dot SS, which is a linked list, right? At position 1 versus RS. Okay, let me just draw that. SMS array linked list at positions 1. You're talking about this particular slot. When I talk about RS, I'm talking about RS over here. So both of them refer to the same objects dynamically. However, from the compiler's point of view, they have different static type. Okay? So now that might be where your confusion might come from. SMS, SSI, has a static type students. RS has a static type resident students. Okay, that's interesting. I haven't really explored that part. Yeah. Yes?
This is happening because student, resident students, and non-resident student all have different versions.
That's correct.
What if their descendant classes didn't have tuition? Would this call the base version?
That's called base version. Yeah. So basically, dynamic binding makes sure the version closest to the current dynamic type is going to be called.
So let's say you had resident student that didn't have tuition, non-resident student did, and student did, right? If resident student and cost tuition, it still calls the base version.
So you're basically saying something like this. Okay? Hypothetically, let's say this. Let's say we got the students is now pointing, right? Remember, students is an array of students. Okay? So this is static type, right? Let's say we got an array over here, okay, 1 and 2, okay? Let's say this is pointing to a resident students over here, and this is now pointing to a non-resident students. Dynamically, they're different, right? So now you're asking the following question. Let's say, and let's assume, for the purpose of illustration, let's say the hierarchy looks like this. We got student here, and then we got resident students, and then we got non-resident students. Let's say tuition is defined over here is effective, where it is a base rate. Let's say for now, let's say in the resident students class, we simply inherit the tuition version. We don't redefine, let's say. Okay? However, now in the non-resident students class, we redefine that. Plus plus, where we say discount rate. So now, how many versions of tuition do we have? 2 rather than 3. So now, going back there, if I say this, SS at position 1 dot tuition, SS at position 2 dot tuition, 1 and 2. For number 1, which version are we calling? The base version, right? Exactly, right? Because now, dynamically, we're talking about resident students. Resident students class itself does not redefine. So we go to the closest one, which is this one here. And then you go to here. For the second one, dynamically, it's pointing to non-resident students. The closest one is itself. So we call this version. Okay, make sense? Good. Yeah, I'll just answer that and they'll come to you. Yes?
So like if you have another class, different class, and you are defining the basic for one of them, but not for the other two. So both of them will call the base class?
Wow, okay. You guys should keep making it more complicated. Okay, sure. How about last one? Okay, no more complication. Okay.
No, it's not complicated.
Okay, no worries. So I'll add it. Okay. You suggest which one? Adding a new class?
Yeah, just another class.
Sure. Okay. To avoid confusion, okay, let's say this. So we have student class. Do you want to have a base version, first of all?
Yeah.
Okay. Base version. And then?
And then
3
3 classes.
classes, okay? Let me just say S1, S2, S3, okay? S1, S2, S3, okay?
Yeah, and you have defined the tuition for only one class,
Only one of them,
but not for the other.
okay. Similar idea. So let's say tuition plus plus over here, only for S1, okay? Similar idea, okay? I can explain that. So let's say students, still, it's gonna be an array of students, statically, right? Dynamically, it can be S1, S2, S3, okay? SS is now pointing to an array, let's say, of 3 elements, let's say, for example, okay? 1, 2, and 3. Let's say 1 is pointing to some S1 object, let's say. 2 is pointing to some S2 objects. 3 is pointing to some S3 objects, okay? So now, if I say SS at position 1 dot tuition, SS2 dot tuition, SS3 dot tuition. Okay, 1, 2, and 3. Okay, now for 1, which version are we calling? The redefined version, right? Only look at the dynamic type. Hopefully now you can see it. So now for that one there, you can see SS1 is now referring to this object here, and it does have, that's the closest one, okay? No problem. For S2 and S3, well, they simply didn't redefine that. So this version, okay. I can go to the code. Which code?
So here, where we're getting, when we say get student dot tuition, the compiler is checking whether or not tuition is a.
Is a feature of the static type of get tuition.
Okay.
Mm-hmm.
But then when it's during runtime.
During runtime, you look at what's being pointed to dynamically. Yes. Again, it's very important to distinguish between compiler time and runtime. Okay.
So if student didn't define tuition, but like a resident student and
Then it wouldn't work. It wouldn't work.
I would get a compile time error.
Mm-hmm. Let me just do one more. Okay. How about we do one more? Just for completeness, since you asked me. Okay. Let's say students, it would be, let's say, linked list of resident students. Okay. And then what I would say is, if I say SS at position 1, let's say, I might do something over here. Okay. That's not a concern of the compiler, right? It doesn't really track your code. If I say SS1 dot discount rate, would it compile? Aha, that's kind of, dude, okay? You wouldn't compile. Okay, you want to explain? Yes?
But if 2% of classes have tuition,
Mm-hmm.
your root class.
Oh no, let's focus on this before I get to your example. So for this one here, SS1, the static type is simply resident students. Does resident students class support discount rate? No, resident student class only support premium rates. Okay, so this does not compile. Okay, and now your question.
The example that was given where 7 classes have a tuition feature, but the base class didn't, that also wouldn't work, right?
That also wouldn't work, yeah. Basically, you just talk about whether the feature is supporting the static type. That's all you check. Okay. All right. Any other questions? Well, we're good? All right. That's important. Good. All right, let's now go. We are done with the return type, okay? So now I want to do a summary slides just to tell you a little bit of design principle. So now, for you, when you do your lab 3, lab 4, or future lab, or the projects, whenever when you have inheritance, what should be the type for the attributes? Let's say if you declare A to be of type T, what should be T? Okay? The design principle is think about what features you might call on A. Okay? Because as soon as you commit to T, T will be the static type. Let's say if you commit T to be students. So that means you can only call tuition, but not discount rate, not premium rates on A. Right? That's something you want to think about beforehand. Otherwise, refactoring will be a pain. Okay? So the example I give to you would be, let's say if I give this particular design to start with, I say S is simply going to be of type statically students. But now, let's say later on, you find that it is so often you actually have to cast your students into maybe resident students or non-resident students. If you have to cast so often, so that means maybe your initial design was wrong. When you have too much cast, that's not a good sign. Okay? It's just tedious to write. Okay, there's a design principle to show you. Okay? Do we have 3 minutes? Maybe? Yes. Thank you. Let's have 3 minutes. Okay, and similar idea for arguments and also return type. Okay? Okay, so now one final thing. If you want to judge for compilation, look at static type. You want to judge for runtime behavior, look at dynamic type. Okay, we keep emphasizing. Okay? I don't have to read off the slides for you. This is something you can take just as a reference. It summarizes all the type checking rule that we talk about for inheritance. Okay, look at them. If you got trouble, let me know. Okay. Now, I want to talk just one thing about generics. I look up the 2030 from last year. I didn't talk about generics, which is good. So that will be completely brand new for everybody. Okay. So now let's just do one exercise together. Okay. So now the way I'm going to talk about generics, before the reading week, we talk about how you can use it. But now we want to talk more about rationale. Why do we need generics in the first place? Okay? We will start with an example without the generics and see how bad it can become. So now let's look at this particular book over here. Let's say we have a classical book, and then we have an array of string. Let's say that's a name, basically 2 arrays. And then we got records, array of any, like an array of objects. Any is like an object, the most accommodating type in iPhone. Let's say we got an empty constructor here to make an empty book. Also, we got add, which will add a pair of string and also any record. And also, we got get. And then, because we can store any record into the book, so we can get anything from there. Okay, notice we got any over here. Okay, so now, I'm going to show you a series of lines. Just tell me which line or which lines will not compile. Okay? I'll show you all. Okay, we got birthday, which is, let's assume we got a date class. Okay? And phone number, string. Also, we got B of type book over here. And also, we got is Wednesday, which is Boolean. And we got create, empty book. And also, phone number is simply this number here. And also, we got, let's say, B.add. Let's say Xuyang, and also some phone number. So this is more like a phone record. And then we got create another birthday here, and then simply this birthday. Okay? And then we say add Yuna's birthday. So we're storing phone number and birthday at the same time, simply because it's an array of any. Okay? And then, so now line number 8, we say it's Wednesday. We simply say now, since Yuna has been put for her birthday into the book, let's get a Yuna's record, which should be a birthday. And then let's assume for the date class, you can have the query get date of the week. It can tell you either 1 for Sunday, 2 for Monday, 3 for Tuesday, etc. Right? 4 will be whether there's a Wednesday or not. So now we got 8 lines of code. Should there be any compilation error? I'll make it easier for you. I'm pretty sure there's no compilation error for 1 and 2. I'm pretty sure. You can skip them if you're struggling with 1 and 2. 3 and 6 seem to be fine too. And 4, right? Aha. Okay. Okay. Anybody else? You may be right, maybe wrong. Okay. I'm happy what you just said. Okay. Okay. Anybody else? Want to try? Which line? Yeah, would you take maybe just 1 more minute? I don't want to keep you too long. Anybody want to speak out for this? Think about this kind of issue here, because this really suggests the very idea about what kind of issue you can run into when you got a record of type any. 8? I also heard 8. 8? Okay, okay. Maybe you got similar reason. Okay, Jordan, you were actually right. Okay. So now let's look at this. I'll emphasize again on Thursday. Give me just 30 seconds. If you look at line number 8, b.get unum. What's the static type? Get any. As far as compilation is concerned, compiler will only check to see whether get day of week is a feature of any. Is it? No. It's of this it's descending class called dates. So compilation error. How can we fix this? However, doing cast in general will run into some trouble for single choice principle. That's something we'll get into. Okay, we'll finish about generics very quickly, and then we'll go to our next design pattern, composite and visitor, the most interesting pattern. Okay. Anyway, think about this example more, and then I'll see you on Thursday.